Welcome to Electronic Geek. In the last video, we saw about Kirchhoff's voltage law. In this video, we will see about Kirchhoff's current law. We will apply the law to a circuit and we will try to find out a nodal voltage which will be verified using LT-Spice simulator. So let's get started. So firstly, we will see what the law states and what does it mean. Okay, so Kirchhoff's current law states that the algebraic sum of all the currents entering and leaving the node is equal to 0. Algebraic means that the value of current is supposed to be considered with the sign as well. Okay, so what is a node? A node is a point where two or more than two branches are connected. A branch is nothing but it represents any two terminal device. Okay, so over here we will see that. Let's consider this diagram. In this, what we can see is this is a node. Okay, current I2 is entering the node, current I1 is also entering the node, current I4 is also entering the node, but I3 is leaving. So as per Kirchhoff's current law, okay, the incoming current is always equal to outgoing current. So we can say that I1 plus I2 plus I4 is equal to I3. Or rather, if you want to write like sum of all the current at a node is 0, then we will assume a thing, okay, as per our convention, when the current is entering the node, okay, which is for the case of I1, I2 and I4, the value of current is supposed to be taken positive. And when it is leaving, we will consider it as negative. So in other way, you can write it as I1 plus I2 plus I4 plus minus I3, okay, because the current I3 is leaving the node, that is equal to 0. So yes, incoming current is equal to outgoing current. So here is a circuit that we are going to solve and we are going to find out this voltage, okay, this nodal voltage. So this is our circuit on LT Spice. Okay. Over here you can see there is a current source of 500 milliamperes. Here's a voltage source of 10 volts. Okay. And this is a resistive network. So first of all, we will assume the current direction at a node. Okay. So at node Vx, what we are going to assume is I, that is 500 milliampere, is entering the node. Okay. And current from this voltage source, okay, is also entering the node. Whereas this current, okay, which will be flowing through this R2 of 2k ohms, is leaving the node. So if you write the KCL equation at this node, okay, incoming is equal to outgoing current. So we will see over here that for this node, so we can write as V1, okay, that is 10 volt, minus this nodal potential we have assumed to be Vx, so 10 minus Vx divided by 1k, okay, which is this resistance. It is nothing but simple Ohm's law. Okay, current is V by R. So this is entering, but this is leaving. So it will be 10 minus Vx by 1k plus 500 directly, 500 milli. So you can write as 0.5. That is equal to the outgoing current Vx minus this ground potential, that is 0 divided by 2k. Now, many a times what happens is while solving the circuits, this ground is not specified. So your first job is to specify a ground. Okay, so that is called as basically a reference node where you can assume the potential to be 0. If you rearrange this equation, you get as 10 minus Vx by 1k minus Vx by 2k equal to minus 0.5 amperes. Okay, this is 500 milliampere. So that's why this is zero point 0.5 amperes. So just basic math over here, that is 20 minus 3 Vx by 2k is minus 0.5. So take this 2k over here, multiply it, you will be getting 1000, and bring this 1000 to the left side, and on adding you will get 1020 is equal to 3Vx, and finally you get Vx as 340 volts. So let's simulate the circuit and try to find out the nodal voltage Vx. I'll simulate it. Place a probe over here and over here. See, it's somewhat more than 339.99 volts. Let's see this. The average value is 340 volts. So this is how you apply Kirchhoff's current law to find out nodal voltages. So I will be covering a few more examples on this law, and we will see how to implement this law in complicated circuits as well. So this is it for this video. Thank you for being till here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubts or suggestions, feel free to put it in the comment section. Thank you for being till here. Thank you so much.